Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, The Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola, and Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a tabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
Name a desert. Let me guess. Sahara? Well, actually, no matter which one you thought of, I'm sure of one thing. It's located somewhere below this line. See, when we hear the word deserts, we usually picture dry, sandy, blazing hot places, and there's not a single one of those above 45 degrees north latitude, or below 45 degrees south. In the south, that kinda makes sense. I mean, if you leave out Antarctica, there's not a whole lot of land down there. But things are different above 45 degrees north. There are tons of land. Countries like Canada, France, the United Kingdom, and a bunch of others. And still, not a single desert. Actually, not a hot desert. Most of the major hot deserts are up in the northern hemisphere, near the tropics of Cancer and Capricorn. And the hottest ones are usually found between 15 and 30 degrees north or south of the equator. Just like the Sahara, where average high temperatures can reach up to 104 degrees Fahrenheit. Together, hot deserts cover almost 15% of the Earth's land area. But if our planet is packed with them, why doesn't a single one appear above this line? I mean, the 45 degrees north latitude. I'll explain. Let's divide Earth into 5 main zones. The polar regions are located at both ends, north and south. Right here, we have the 2 temperate zones. And finally, right in the middle of the globe is the tropical zone. Now, the line we're talking about sits in the temperate zone, in a colder area. Because the farther you go away from the equator, the colder it gets. Actually, the average annual temperature drops about 1.2 degrees Fahrenheit for every degree of latitude you move north in the northern hemisphere. And cold weather is the main reason hot deserts don't form above this line. It turns out that as you move farther north from the equator, the sun's rays hit the Earth at a more slanted angle. That spreads the solar energy over a larger area, which means less heat is concentrated in one spot. Basically, these regions just don't get as hot. And it's one of the reasons why countries like Finland are much colder than Colombia, for example. Another reason temperatures are lower in this zone has to do with something called albedo. Basically, this term refers to the amount of sunlight that a surface reflects back. Let me give you an example. Every surface on Earth both reflects and absorbs sunlight, but in different amounts. Take snow, for example. It can reflect up to 90% of the sunlight that hits it and only absorbs about 10%. That's what gives snow a high albedo. And it's totally different with sand, which has a lower albedo. In places like the Kalahari Desert, down in southern Africa, it's about a 50-50 situation. Most of the year, roughly 50% of the sunlight gets reflected around there, and the other 50% is absorbed. The heat absorbed by the sand is part of why it gets so hot in dry places like deserts. I mean, hot deserts. Simply put, sand soaks up more heat, while snow reflects most of it. This is one of the reasons why snowy areas stay much cooler. So the closer you get to the polar zones, the easier it is for sunlight to be reflected instead of absorbed. And that helps explain why there aren't any hot deserts around those parts. Then, we also have atmospheric patterns. Let's just say that the air patterns change a lot once you go above that 45-degree line. That's because this region is controlled by a wind belt known as the Ferrel Cell. Okay, so Earth has three main convection cells. You can think of them as big loops of moving air. Warm air rises, cools down, sinks, and then the cycle repeats. At the top and bottom of the planet, we have the polar cells. Right in the middle are the Hadley cells, and sandwiched between those two are the Ferrel cells. Now, everything that happens between these three cells can get a little complicated, but for today, the main thing to know is this. In those middle zones, the warm air that comes from the tropics meets the cold air from the polar regions. So, Ferrel cells play a big role in moving heat from the equator up toward the poles. This flow of warm air helps smooth out the temperature differences between the tropics and the polar regions. And that's what shapes the weather in places like North America, Europe, and parts of Asia. In the mid-latitudes, the Ferrel cell keeps the air moving around so much that hot, dry air doesn't really get a chance to settle. So, those regions end up with more moisture, more clouds, and even storms, rather than dry, desert-like weather. That's why you don't usually see hot deserts around 45 degrees latitude. Basically, what I'm trying to say is that the Ferrel cell makes the weather less stable. And that's very different from what happens in the Sahara Desert, for example. Over there, temperatures don't change all that much throughout the year. Just expect it to be hot. When you put all these factors together, it helps explain why hot deserts are mostly limited to the middle parts of the Earth, and why you'll never find a Sahara or Kalahari-style desert in places like Canada or Sweden. But that doesn't mean we don't have any deserts above the 45-degree line. Turns out, deserts don't always have to be hot and sandy. In fact, they can look like this. Yep, I'm talking about the Arctic. Because the actual definition of a desert isn't just some hot, dry, sandy place, it's really any area that gets very little precipitation. In other words, an area where it doesn't rain much. And it usually gets no more than 10 inches of precipitation per year. So, no matter if the weather is hot or cold, deserts are really dry places with hardly any vegetation around. That makes it pretty tough for animals and plants to live in those environments. If you think about it, that means the biggest desert on Earth is Antarctica. It covers about 5.5 million square miles, just endless ice flats as far as the eye can see. It's also the coldest desert on the planet. even colder than the Arctic, which is the other polar desert. Temperatures there can drop as low as minus 128.2 degrees Fahrenheit. If you look at the Earth, about 33% of its land is desert. Now, pay close attention to the ones located between 15 and 30 degrees latitude. These are called tropical deserts. But can you notice something curious about their locations? Most of them are found on the western edges of continents. And there's a reason for that. Actually, 4 main reasons. First, the winds that bring rain usually blow from the east. When they move across the land, they drop most of the rain early on. By the time these winds reach the west side, they're dry, so there's no rain left for those areas. That already makes things pretty dry. Second, in the western margins of continents, the air usually goes down instead of up. When air goes down, it gets warmer and can't form clouds, so again, no rain. Third, if there are mountains nearby, they can block the rain too. One side of the mountain gets all the moisture, and the other side, called the rain shadow, stays dry. And lastly, the ocean near these places often has cold water. Cold water cools the air above it and makes it calm, so clouds don't form easily. No clouds means no rain. So when you put all of that together, it helps explain why those tropical deserts seem to prefer one side of the continent more than the other.
You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light-years wide. For comparison, just 1 light-year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around minus 63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, Even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny-tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we've found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell. which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, Sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100. On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. and water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top $70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia Fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone and how it could eventually lead to a major earthquake.
Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so is pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.
You're chillin' in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it. Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenoiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare, so for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and Meconia, a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the Big Island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, while Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands. A bridge, a very helpful structure that traces back to the Neolithic times. The oldest bridge in the world, at least the one that is still standing, is the Arcadico Bridge, built more than 3,000 years ago. But there's a river you cannot cross using a bridge, the Amazon River, the largest and longest river in the world. Okay, the Nile River is actually the longest river in the world, but the Amazon wants both titles for itself. The Amazon River is born in Peru and crosses Colombia and Brazil until it reaches a massive delta at the Atlantic Ocean. Its waters travel a longer distance than Frodo and Sam, and yet not a single bridge has ever been built over it. Why is that? First of all, seasonal floods change the size of the river. During dry seasons, the Amazon is about 3 miles wide. But during heavy rains, it can get up to 30 miles wide in a few weeks. Not only that, but the flood also makes the river change its position. Now imagine trying to build a bridge in a place where the ground turns into water for about 4 months. Not an impossible task, but not the easiest one either. Now, if you look back at your geography classes, you might remember that the soil of the riverbank can be very soft, especially in the Amazon, which means it can erode and shift. Heavy rains also create marshes, a type of wetlands that actually reduces the magnitude of the floods and purifies the water. It's also home to many animals. This means that to build a bridge, part of this wetland would have to be drained, which would ruin the lives of all those animals. Besides, the foundations of said bridge would have to be deep, and that would cost a lot of money. The rain creates yet another problem for the potential bridge. It increases the river's water level by 13 to almost 50 feet. Of course, bridges have been built in deep rivers before, like the Padma Bridge, a gigantic structure with a foundation of 417 feet. But because the soil of the Amazon River can erode easily, a bridge would have to be built using floating structures, known as pontoons, and they're not helpful in a river that changes depth whenever it feels like it. Next on our list of things that are a problem to human endeavors is the Amazon rainforest. This forest spreads over 9 countries and is so big and so dense it could cover about half of Europe. This means that a bridge would almost likely connect one patch of the forest to another. A pointless improvement to the lives of capybaras and jaguars. Of course, the real users of such a bridge would be humans. Most people live around the tributaries of the Amazon River, not around the river itself, because who wants to live like a beaver at a dam? There's even a state called Amapá on the left side of the Amazon River that is completely cut off from the rest of Brazil. You could easily take your car and visit its neighbor, a place called French Guiana. But if you wanted to go to another part of Brazil, you'd have to find other means of transportation. Aside from small riverside populations that live right on the riverside, of the Amazon, bigger cities were built near tributary rivers, like the Rio Negro, which has a bridge, by the way, and the Nanay River in Peru. The bridges that go over the Nanay and the Rio Negro are the only 2 bridges over the rivers in the Amazon basin. The lack of good roads and highways inside the Amazon also makes the creation of bridges a pointless endeavor. Back in the 70s, humans had big ideas on how to explore the Amazon ever more, which is why they decided to build a highway which would cut the Amazon basin from left to right. The road, called the Trans-Amazonian Highway, was supposed to bring people to the heart of the Amazon. But it seems like the difficulties of building more than 2,000 miles of road inside a dense rainforest were not foreseen. Halfway through, the project was abandoned because it was super expensive and problematic. Nowadays, highways in the Amazon basin are always flooded, filled with holes and mud. This whole situation creates a ripple effect. People don't live near the river because it's hard to access it. The roads don't go there either, because it's hard to build them. Which in turn makes even fewer people want to settle on the banks of the Amazon River, because they have no roads to get them there. So, if there are no roads and no bridges, how do people live there? You're not gonna believe this, but the riverside population uses a very old but reliable invention called a boat. The Amazon River is fully navigable, and the people that live there use it like a road. Much like motorcycles, cars, and buses, the Amazon River has canoes, speedboats, and ferries. There's even a very specific ferry called Obidense, transporting people to the municipality of Óbidos, hence the name. Locals do everything on boats. They even have a boat hospital that floats around and visits riverside populations, and a boat bank, so you can do all your bank-related things while looking at the vastness of the Amazon. Honestly, genius invention. The downside to this lack of bridges is that it stops us from exploring the truly hidden gems of the world. In the Amazon, for example, there are over 10,000 undiscovered archaeological sites. We may never be able to dig out stuff like fortified villages, geoglyphs, and many other structures. It would be pretty neat to go full-on Lara Croft in the middle of the Amazon, but these findings are tucked deep in the heart of the forest. At the same time, only on a boat are you able to witness the crazy phenomenon of the unmixed waters of the Rio Negro and the Solimões on the Amazon River. For more than 3 miles, these 2 tributaries of the Amazon River flow side by side without mixing. The speed and the temperature of these waters are different, so you'll see a river that looks like coffee and Coca-Cola mixed. This awesome phenomenon is called the meeting of waters. But the Amazon River is not the only river in the world deemed bridgeless. The Congo River, the second longest river in Africa, only has 1 bridge crossing it. The 2 Congos, yes, there are 2 different countries in the world named Congo, are separated by the Congo River, and so far, no roads connect them. Also, fun fact, some geologists believe that back when Gondwana existed and the continents were all cuddled together, the Amazon and the Congo River were one river connected to each other. Another place with a lack of bridges is the east side of the Thames in London. The west side of the river is narrower, which makes building a bridge easier. There are about 33 bridges on the west side alone, but if you want to cross the river from the east side, it's gonna be a hassle. The thing is, back in the 1800s, shipping companies decided that building too many bridges over the Thames was too expensive, because this was a shipping route and the bridges would have to be taller than usual. The structure would also have to be long, since some parts of the Thames are about 1,870 feet wide. But building long bridges is not a problem per se. In Rio de Janeiro, for example, you can find the Rio Niterói Bridge, which is about 8.26 miles long. Back when it was built in the 70s, it was the second longest bridge in the world. The bridge is so long that in 2018, a girl was born while her mother was crossing it, and now the birthplace in her birth certificate is literally the bridge. There's also no U-turn on it, so if you drive onto the bridge by mistake, you're in for a long drive. So next time you feel like exploring the Amazon, remember to pack your own boat. People living in Hawaii need to make at least twice the average salary in the rest of the US to live comfortably. Those who aren't ready to pay $5 for a gallon of milk have to look for happiness elsewhere. And year after year, the state makes it to the top lines of the population loss rating. While the local middle class is leaving, Hawaii is turning into a heaven for billionaires. Just 37 of them already own 11% of all the private land in the Aloha State. Larry Ellison, co-founder of the Oracle Corporation, bought 98% of the island of Lanai, including the grocery store, the only gas station, and the community newspaper, all for a nifty sum of $300 million. This makes him the boss and landlord of everyone on the island. Mark Zuckerberg, the Meta founder and CEO, is building a huge compound on Kauai with more than a dozen buildings, at least 30 bedrooms and bathrooms, a tunnel leading to a 5,000 square feet underground bunker, and 11 tree houses connected by intricate rope bridges. The local residents with ancestral rights to this land lost in court and had to put it up for auction. The Malaysian tycoon Kvek Leng Khan owns a third of the island of Molokai through his business empire. Of course, these and some of the world's richest people create new jobs and invest in development projects on the islands. But still, nearly 2/3 of the locals believe that their state is being run for tourists at the expense of the residents. A lot of famous people like to live in Wailea and Makina in Maui because it's peaceful and gives them the privacy they want. Oprah Winfrey has a big house up in the local hills. Jeff Bezos, the founder of Amazon, reportedly bought a huge house by La Perouse Bay for $78 million. Other famous people who live in Maui include Clint Eastwood, Mick Fleetwood, Jim Carrey, and Alice Cooper. When you visit Maui, you can see a special Hall of Fame display at the airport showing those celebrities. It's supposed to celebrate their ties with the island, but the local people feel like it only highlights the huge gap between the new super wealthy residents and the local people who can barely afford to live there. As the rich and famous keep buying property across Hawaii, home prices continue to rise. It's more expensive to buy a house here than in Washington, D.C. or California. Part of the reason for such high pricing is how the land itself is formed. Hawaii is bigger than most people think, but it's made up of lots of separate islands that are spread far apart. Even though the islands are big, not all of the land can be used to build houses or neighborhoods. Unlike most of the US, which has a lot of flat land and gentle hills, much of Hawaii is made up of steep, rocky mountains and rough terrain. This kind of land is very hard to build on or live on. Because of this, most of the people on Hawaii, about 1 million of them, live on the island called Oahu. The other islands, like the Big Island, have far fewer people. There isn't enough land for everyone, and that makes it hard for people who have lived in Hawaii their whole lives to afford a place to live.
Tourism makes up 21% of the state's economy. Most of the visitors come from the United States and Japan. Tourists bring in tons of money, but there's a problem. Depending too much on tourism can be risky for Hawaii. In the recent years, because of we all know what happened, a health rule called the Conditional Sail Order stopped cruise ships from coming to Hawaii for health safety reasons. Many other tourist activities, like visiting beaches or attending events, were also shut down. With fewer visitors, Hawaii earned a lot less money, which hurt the economy. To avoid this problem in the future, Hawaii has been trying to make money in other ways besides tourism. One idea is to invest more in fishing, but this hasn't been easy. At some point, there was too much fishing going on here, and now Hawaii has to bring in 63% of its seafood from other places instead of catching it nearby. There are farms here that grow pineapples, macadamia nuts, coffee, and produce milk. But now, farming isn't as important as it was 100 years ago. Probably one of the reasons is that it's more profitable to sell the land for houses or hotels than to use it for farming. This change made Hawaii even more dependent on tourism and made living in the Aloha State so very pricey. Honolulu is reported to be the 7th most expensive city to live in the US. A family of 4 spends around $8,000 a month here, and a single adult will have to pay, on average, $2,500. Food alone costs around $500 a person for 1 month. Most of the food in Hawaii, about 85 to 90%, comes from faraway places. Since it has to travel more than 2,500 miles to get there, around 1/3 of all the food spoils along the way, especially because Hawaii is warm and humid. This waste makes things more expensive because stores know they'll lose some of their products and charge more to cover their losses. There aren't as many stores competing with each other. If stores don't compete, they have no reason to lower their prices. On top of that, they have to pay a lot for things like rent and electricity, so they raise their prices to make up for those costs. Speaking of electricity, an average bill is around $200, which is almost 90% higher than the national average. Yep, the Aloha State has the highest energy costs in the country. And perhaps that's why people in Hawaii use the least amount of electricity compared to other states. But their bills are still much higher. The main reason is the price per unit of electricity, called a kilowatt hour. 1 unit of electricity costs almost 40 cents. To compare, Utah has the cheapest rate at just 10.91 cents. It's so expensive in Hawaii because most of the electricity comes from oil, and that oil has to be shipped to the islands. Since Hawaii depends so much on oil, energy costs go up and down with oil prices. On top of all that, the income tax is some of the highest in the country. A quarter of all households in Hawaii spent more than their income in 2024. To survive, people used savings and credit cards and cut expenses. They also had to work more hours or get an extra job. They were forced to sell their belongings and borrow money from relatives, banks, or other lenders. Almost half of residents are in the category called ALICE, and it has nothing to do with Alice in Wonderland. It means asset limited, income constrained, employed. More than 1 in 3 residents lives below the ALICE annual income threshold. And then there's also legislation that further complicates things for Hawaii. It says that any goods shipped between places in the US must be carried on ships that are owned, built, and run by Americans. This makes shipping much more expensive because US ships and crews cost a lot more than ships from other countries. Most of the world's ships don't follow these rules because they're registered in countries like Panama. Because of this, Hawaii can still get goods from places like East Asia using cheaper ships, but if they want something from the mainland US, it costs way more money. In fact, this law costs Hawaii over $1 billion every year. This law also makes it really hard for Hawaii to grow businesses because everything is so expensive. The cost of insurance is also going up. This is because the islands are hit by natural disasters like hurricanes and storms more often now. All of this adds up to making life in Hawaii even more expensive. But even despite all that, the state steadily lands high in studies on well-being. Even people who can barely afford a living are mostly happier, or at least less unhappy in Hawaii than in other states. I guess the strong community support, a clean and fantastically beautiful environment, and the ability to have beach parties all year round make up for many hardships.
So it turns out that so-called rich countries are facing a big problem. People are not having kids. Not enough, at least. On average, women need to have 2 children to keep things balanced, but they're only having 1, or none at all. This issue comes down to the fertility rate, or simply the average number of kids a woman is expected to have in her lifetime. When that number's too low, it means more people are passing away in these countries than being born, and that can destroy the economy. Think of a rich country – the US, Germany, Japan. Great! Pick any wealthy nation you like, and I can promise you one thing – its fertility rate is below 2.1, and that's a problem. Here's why. Meet Mary and John, and over here we've got Jack and Lucy. That's 4 people total. Now, both couples get married. Mary and John have 2 kids, but Jack and Lucy only have 1. Now, what does that mean? Simple math. We're down by 1 person. And if this keeps happening, generation after generation, the population starts to shrink. The situation gets pretty scary when we zoom in on certain countries. Take Spain, Italy, or Poland. These countries have some of the lowest fertility rates in the European Union, with women there having, on average, just 1 kid. And that's a big problem, because it drags down entire economies. Picture a triangle. Young people and workers at the bottom and the elderly at the top. In many rich countries, that bottom part is shrinking fast, with fewer babies being born each year. So it's like this triangle is flipping upside down. Fewer young folks and workers, but more and more older people. With fewer workers and more retirees, the economy struggles to stay balanced. It's like the domino effect. Fewer people working means fewer people paying taxes. Meanwhile, the older population at the top keeps growing, and now we have a way bigger group depending on pensions and stuff like Social Security. So we're left asking, who's going to pay for all these retirements? Now, some countries are in hotter water than others, and South Korea is really feeling the heat. They've got more and more people getting older, while fewer and fewer babies are being born. In fact, they've got the lowest fertility rate in the world. In 2023, it hit rock bottom. 0.72 births per woman. Now, personally, I don't know how you can have 3/4 of a kid, but hey, that's statistics for you. Meanwhile, if things keep going like this, Korea's population could shrink by half by 2100. Over the last 20 years, their authorities have invested at the equivalent of $286 billion in this issue, and they've rolled out a bunch of incentives to turn things around. First up, pocket money. If a married couple in Korea decides to have their first kid, the government hands over about $10,000 split into monthly payments to help out. While that might sound impressive, it's only about 3 times the average monthly wage. And in Seoul, one of the most expensive cities in the world, that doesn't go very far. Next, a home. Paying rent in Seoul is insane, but the government doesn't want people to leave the capital because of it. So they're stepping in. Recently, they've promised to give families around $300 a month to help with housing, until the kid turns 2. Then again, $300 seems great, but it only covers about 11% of the rent for a 3-bedroom apartment in the city center. And last but not least, health care. Hospital bills are covered, but the couple must be married, on paper and everything. South Korea came up with all this to fix the problem. Otherwise, their population might get older, poorer, and more dependent on others for care. But when you think about it, all these incentives really come down to one thing: giving out cash. Even so, their demographic problem hasn't gotten any better. So the authorities had to come up with more creative solutions, like offering jobs with flexible hours for parents with kids under 5. And they can borrow things like toys or strollers from the government. totally for free. So, why don't women want to become mothers? There's a bunch of reasons. But one of the most important is work. Women are getting more education and grabbing more opportunities in the job market than ever before. But a lot of jobs have crazy hours, with people working late every single day. So many women get stuck in that cycle, waking up early, going to work, coming home late, and sleeping. Then it all starts over the next day. They don't have time to meet a partner, and even less time to raise someone. In fact, education in general is one of the biggest reasons why birth rates are dropping. Spending so many years in school, then in college, means women are pushing back the age they have their first kid. Once they finish their education, they often want to focus on work and building their careers before starting a family. So they're not becoming moms in their teens or early 20s anymore. And by the time they hit 30, things aren't much better. Sure, they might finally land a stable job, but most employment policies still don't offer enough support for childcare. But it's not only education. Younger generations are getting delayed in, well, everything. I mean, it's way harder for them to tick off all the adulting boxes, like having a well-paying job or buying a nice house. And these things are usually a big part of whether people decide to start a family or not. Another reason people aren't having kids: putting a new human into this world is expensive and time-consuming. The average childcare costs in Australia, for example, have gone up faster than inflation. School tuition, even for public schools, takes a big chunk out of parents' budgets. Think about it. Computers, uniforms, field trips, extracurricular activities – all that adds up to the cost of financing someone's education. Over 13 years, parents spend over $80,000 on public education. And if we're talking about private schools, that number jumps up to almost $350,000. And don't worry, these costs are just for one kid. Now imagine having 2 or 3. So what is the solution? Well, there are 2 ways to tackle the problem that don't involve pushing the population to have more kids. Nations can keep their population healthier and employed longer, like what Singapore is doing. They're putting a lot of effort into raising the retirement age, offering midlife training, and encouraging companies to hire older workers, like those over 69. Another way is to encourage people from other countries to come in, especially young ones who are ready to work. That's, for example, the strategy Canada uses. Now, if the goal is really to get women to have more kids, a lot of countries use the baby bonus strategy, basically giving money and benefits to families, just like South Korea does. The problem is that some experts say it is pretty ineffective, as financial incentives don't address the complexity of the issue. For them, what these wealthy countries need to do is offer better career and housing opportunities for young people, like giving incentives for companies to offer more flexible hours or work-from-home options for young parents. They also need to push strategies to lower the cost of housing, especially in big cities. Plus, they need to focus more on the aging population, using technological innovations to support them. That would help not just parents, but families as a whole. So, what do you think?